Hi, welcome to this series of videos on GMAT quantitative reasoning section preparation. Today our topic will be probability. The quantitative reasoning section has two types of questions, the data sufficiency question and problem solving. Problem solving is your basic question with 5 answer choices. You select the one that suits the best, and data sufficiency, you have one question and 2 statements. You will have to check whether the information given in the statements is sufficient to answer the question. These are the options for the answers for all data sufficiency question. It is standard. So, answer option A is when statement 1 alone is sufficient, but statement 2 alone is not sufficient. Answer option B is when statement 2 alone is sufficient, but statement 1 alone is not sufficient. Answer option C is when both statements together are sufficient, but neither statement alone is sufficient to answer the question. Answer option D is when each statement alone is sufficient to answer the question, and answer option E is when statements 1 and 2 together are not sufficient to answer the questions. So, let us look at today's problems. This is our first question. When choosing two animals without replacement, what is the probability of randomly choosing 2 cows out of all the animals at Old MacDonald's farm? Okay, statement 1 says the ratio of number of cows to the number of goats in the farm is 5:6, and statement 2 tells the only animals in the farm are cows and goats. Okay. So, what is the question asking us? Question is asking us what is the probability of randomly, when 2 animals are chosen without replacement, what is the probability of randomly choosing 2 cows out of all the animals? And statement 1 tells us the number of cows is to the number of goats is 5:6. So, except for this we have no information. So, we do not know if there are more animals other than cows and goats, and we also do not know the exact number of cows to calculate any of the calculate the probability of randomly choosing 2 cows. So, this information is not sufficient. Now, let us look at statement 2. Statement 2 tells us that only animals at the farm are cows and goats. Okay, but still you do not know the number of cows to say or the number of goats. So, therefore, this in itself is also not sufficient to answer the question. Now, if you are looking at statement 1 plus 2 together, you have that cows is to goats is 5:6. So, therefore, cows is 5x, goats is 6x, okay, and the total will be, because there are only cows and goats, the total is number of cows plus number of goats, that is equals to 11x, but we still do not know the exact number of what x is. Let us see if we can calculate this. If you are choosing the probability of randomly selecting 2 cows, it will be the number of cows, that is 5x C2 divided by the total, that is 11x. After that it will be C2. If x is equals to 1, you will have 5 C2 by 11 C2. If x is equals to 2, it will be 10 C2 divided by 22 C2. So, we do not know what x value is, therefore, we cannot tell what the probability of, it can be 5 C2 by 11 C2, 5, which will be equals to 5 into 4 divided by 11 into 10, which is different to if it is x is equals to 2, it will be 10 C2 by 22 C2, which is 10 into 9 divided by 22 into 21. So, these two values are very different, therefore, this information is also not sufficient to answer the question. So, the answer option is what? Statement 1 alone is not sufficient to answer the question, statement 2 alone is not sufficient to answer the question, and statement 1 and 2 together are also not sufficient to answer the question. That means, answer is answer option E. Let us move to the next question now. In a classroom, one student is to be selected at random to solve a question. What is the probability that a girl will be selected? Okay. And statement 1 says 2/5 of the students are in the classroom are boys, and statement 2 tells 15 of the students in the classroom are boys. Okay. So, you want what? You want the probability that a girl is selected. What is the probability that a girl will be selected? They are choosing just one student at random. So statement 1 says that 2/5 of the classroom are boys. So the boys fraction will be equals to 2/5. So therefore the girls fraction that is left out will be what? 3/5. So if there are x students, that is 5x students in the class, number of boys will be 2x and number of girls will be 3x. So therefore the probability that a girl is selected will be equals to 3x divided by 5x, which will be 3/5. Okay, so this is clearly sufficient to answer the question asked. So this is sufficient. Let's look at statement 2. Statement 2 says 15 of the students in the classroom are boys, but we do not know how many girls are there, and hence we do not know what the total will be. Therefore, you cannot give the probability of a girl being selected. So this information is clearly not sufficient to answer the question. So when statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question, answer option becomes A. Let's move to the next question now. What is the probability that it will rain on each of the next 3 days if the probability of raining on any single day is the same in that period? Assume that the probability of rain on one day is independent of the probability of rain on any other day. Okay, statement 1 says that probability of no rain throughout the first 2 days is 36%. The probability of rain on the third day is 40%. Okay. So what is the question asking? What is the probability that it will rain on each of the next 3 days? If probability of raining on any single day is the same in that period. Okay. So probability they are asking of rain on next 3 days, and they are saying probability of rain on each day will remain the same. Okay. So statement 1 is saying that probability of no rain through the first 2 days is 36%. If you say probability of rain on any one day is equals to x, then probability of no rain will be equals to 1 minus x. And this will remain standard because they are saying that assume that the probability of rain is same on any single day, is same in that period. So probability of no rain will also be same. So probability of no rain throughout the first 2 days means 1 minus x, that is the first day, into 1 minus x, that is the second day, is equals to 36%, which is 0.36. So you have 1 minus x whole square is equals to 0.36. 0.36 is nothing but 0.6 whole square. So you have 1 minus x is equals to 0.6. So therefore x is equals to 0.4. So which is nothing but 40%. There is 40% chance of rain on any one day. So therefore this information given is sufficient to answer the question. Now let's look at what statement 2 is saying. The probability of rain on third day is 40%. So probability of rain on any day is going to be the same as it is on the third day, which is equals to 40%, which is equals to 0.4. Therefore, this information is also sufficient to answer the question. So, when statement 1 alone is sufficient to answer the question and statement 2 alone is sufficient to answer the question, answer option is D. Let's move to the next question. A box has some red and some green balls in it. There are no balls of any other color. Some of these balls are heavy and the rest are all light. What is the probability that a heavy red ball is picked out of the box? The probability of picking a heavy green ball is 20% and the probability of picking a light ball is 40%. So let's look at the question. The question is asking what is the probability that a heavy red ball is picked. So the probability that a heavy red ball is picked is equals to what? Okay, they are saying there are some red and there are some green balls. There are only two types of balls, that is red and green, and there are only two types of balls, that is heavy and light. Okay, statement 1 is telling us that the probability of picking a heavy green ball is equals to 20%, which is equals to what? 0.2. But you do not know what the light green balls are or what the heavy red balls are or the number of probability for the light red balls. We do not know any of those probabilities. Therefore, this information is not sufficient to answer the question. Now, looking at statement 2, the probability of picking a light ball the probability of picking a light ball is equals to 40%, which means that the probability of picking a heavy ball is 60%, either they are light or they are heavy. But out of those heavy balls, you do not know how many are heavy green or heavy red. So, you cannot estimate what is the probability of heavy red balls. Therefore, this information also is not sufficient to answer the question. So, now let us say statement 1 plus statement 2. So, they are saying that the probability of light ball is statement 2 is saying the probability of light ball is 40%. So, let us say there are 100 balls, let us assume there are 100 balls in total. Then the number of light balls is equals to 40 by 100 and the number of heavy balls will be equal to 60 divided by 100. Out of this, you know that the heavy green balls are 20%, that is equals to 20 divided by 100, 20 out of the 100. So, therefore, the remaining heavy balls, that is out of 60, 20 are green. So, therefore, the remaining balls will be 60 minus 20 divided by 100, which is equals to 40 by 100. So, out of the 100 balls, there are 40 heavy red balls and the probability is 40 by 100, which is equals to 0.4. Therefore, this information together is sufficient to answer the question. So, when you have statement 1 alone is not sufficient to answer the question and statement 2 alone is not sufficient to answer the question, but statement 1 plus 2 together are sufficient to answer the question, answer option becomes C. Let us move to the next question now. A certain jar contains only B black marbles, W white marbles and R red marbles. If one marble is to be chosen at random from the jar, is the probability that the marble chosen will be red greater than the probability that marble chosen will be white? Okay. So, the question is asking us, if one marble is chosen, they are choosing one marble and they are asking that is the probability that marble chosen will be red, that is probability that the marble is red, will it be greater than the probability that the marble chosen will be white? This is what the question is asking. So, statement 1. So, probability that it will be red is nothing but R divided by R plus B plus W, and this probability that it is white is W by R plus B plus W. So, this is what the question is asking us. Let us look at the first statement. First statement is saying that R plus B plus W is greater than W by B plus R. So, you can add 1 on both sides of inequality, it remains unchanged. So, this will become when you take B plus W, R plus B plus W is greater than when you take B plus R as this thing, LCM W plus B plus R is equal to 1. So, R plus B plus W are all probabilities, so they will be positive. So, B plus R plus W is always positive. So, you can cancel out two positive quantities on either side of inequality, the inequality still remains the same. So, that is a concept we have seen in while doing lot of inequality problems. B plus W will be greater than 1 by B plus R. Again, B plus W is also positive, B plus R is also positive. So, if you cross multiply, the inequality still remains unchanged. So, B plus R is greater than B plus W. Now, both sides you can subtract B and the inequality sign will remain the same. So, B plus R minus B is R, B plus W minus B is W. So, R is greater than W. So, we can easily say that yes, here also R plus B plus W on both sides can be cancelled. So, we are in effective asking if R is greater than W. So, we got that answer that yes, it is greater. Therefore, this information is sufficient to answer the question. Now, statement 2 says B minus W is greater than R. So, which means B is greater than R plus W, but we cannot from here say whether W is less than R or it is greater than R. We cannot give the information. So, this information is not sufficient to answer the question. When statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question, answer option becomes A. Let us see the next question now. A group of students, no two of whom are same height, are lined up next to one another. What is the probability that they are lined up in order from shortest to tallest? Statement 1 says there are 4 students in the group. Statement 2 says 3 of the students in the group are females. Okay. We need to find the probability that they are lined up in order from shortest to longest from left to right. So, let us say, so the first statement says there are 4 students in the group. So, 4 students, you have 4 places, 1, 2, 3, 4, left to right, you want tallest to the shortest. So, the way that you can arrange them in such a way is only one way. The total number of ways that 4 students can be arranged in 4 places will be 4 factorial way. So, there is only one way that is correct, which will give you tallest to the shortest from left to right, and that total arrangements is 4 factorial. So, 1 by 4 factorial, that is 1 by 24 is the probability. So, therefore, this information alone is sufficient to answer the question. Now, statement 2 says there are 3 of the students are females, but we do not know how many males are there, and that is why we do not know the total number of students. So, we do not know how to arrange, how many ways are there to arrange them. Therefore, this information is not sufficient to answer the question on its own. When statement 1 is sufficient to answer the question alone, but statement 2 alone is not sufficient to answer the question, answer option becomes A. Let us move to the next question now. If a pencil is selected at random from a desk drawer, what is the probability that the pencil is red? There are 6 black and 4 orange pencils among the pencils in the drawer, and statement 2 says there are 3 times as many red pencils in the drawer as pencils of all other colors combined. Okay. So, you want what the probability of the pencil selected will be red. What is this equals to is what your question is asking. Statement 1 says there are 6 black and 4 orange pencils among the pencil drawer, but they do not say anything about how many red pencils are there and how many more other colored pencils are there. We have no information about that. We need the number of red pencils divided by total number of pencils to find the probability of a pencil selected being red. So, therefore, this information is clearly not sufficient to answer the question. Now, let us look at statement 2. Statement 2 says there are 3 times as many red pencils as in the drawer as the pencils of all other colors combined. So, if you say that all other is x, red, the number of red pencils will be 3x, and the probability that the pencil selected is red is equals to 3x, that is the number of red pencils divided by the total number of pencils, that will be 3x plus x, which is equals to 3x by 4x, which is 3 by 4. Therefore, this information is clearly sufficient to answer the question. Therefore, answer option when statement 1 alone is not sufficient, but statement 2 alone is sufficient to answer the question, answer option becomes B. B is our answer. So, those were some sample problems on the topic of probability for your data science type of question, data sufficiency type of question. I hope they were clear. Thanks for watching.